Hey everyone! In this video, we will discuss the derivative of the function x to the power n, where x is the independent variable and n is any integer except -1. Let us start by understanding how the function x to the power n works when n is positive. We can write x to the power n as a multiplication of x with itself n times. This is the fundamental meaning of powers. Then we can see that the main operation happening is multiplication. And to understand this, we will try to visually represent multiplication. Let us take an example to understand this better. A simple multiplication of 2 times 2 will result in a product of 4. To see how to get 4, we would need to break down the 2 times 2, where each 2 will be broken down as 1 plus 1. We can express this as a relationship graph, where the lines show which term is multiplied by which term, and the sum of all these values will give us the total product, which we can verify as 4. Using this example, we can represent the product of x to the power n in a similar manner. Since we are interested in the derivative, we would need the change in the function x to the power n for a small change in the independent variable x. Therefore, when we increase the value of x by a small value dx, we can visualize the change in the function in this manner. To isolate the change, we would need to observe the fact that the changes involving the multiplication of more than one dx will result in values that are too small to be taken into account and can be ignored. So our focus will be on only those terms which involve a single dx multiplication. To get such a term, the only possibility is that once x is multiplied, n minus 1 number of times, and then it should be multiplied by dx of the remaining column. And as we can see, if there are n columns, then we will have n unique ways of doing this, which when added up will give the total change in the function due to the change in the independent variable x, as we can see is n times x to the power n minus 1 times dx. So now that we have the change, all we need to do is to take the ratio of the change in the function to the change in the independent variable x, which will give us n times x to the power n minus 1. But what about when the value of n is negative? When the power becomes negative, the x to the power n term will go to the denominator. Now, if we represent each column as 1 by x, then the multiplication will have a similar graphical representation. But the change in each column will be minus 1 over x squared times dx. If you are interested in the proof of this, then click on the I button to know more, or else you can take that as a fact from 1 by x derivative equation. Now, to find the change in the function, we can take the multiplication of n minus 1 columns, which comes to the value 1 by x to the power n minus 1. This quantity is then multiplied by minus 1 by x squared times dx, which will give the final value as minus 1 by x to the power n plus 1. Notice that there are n ways to get the same value, and the addition of all these quantities will give the total value of the change in the function. Then we would have the change in the function. All we need to do is to take the ratio of the change in the function to the change in the independent variable x. This will give us the final derivative for the function x to the power n when n is negative. There you go. Now you know how to visually prove the derivative of x to the power n function. Now you can show off among your friends that you know something that they don't. If you like this video, then like and share it with your friends and subscribe for more amazing content.